Welcome to another video of the introduction in R. This time we talk about indication and statistical inference. So we take care about the functions lm and glm, and we talk about how to indicate properly. So have fun and like and subscribe. We always start with the remove function to clear our environment. Then we start with the library, and there we get the package datasets. And then we get 4 different datasets and put it into objects. So then we have a few on D1. It looks like that. So then we have different kind of ways how to save the data. So, and we want to ask which kind of storage does D1 have. So we ask, is it a matrix? Okay, it's not a matrix. Is it a data frame? It's also not a data frame. Is it a list? It's also no list. So we have to ask about the structure, and there we get hopefully our final answer. Okay, it's a time series. So there are different kind of data storages, and one of them is list. A list is it's like a trash can full of everything. So you can put every data object inside of a list. You can also put lists inside of lists. So a list is very practical because it has no requirement for our data. So this is a very nice way to store data. So our data has not to be in the right column size or the right row size. That doesn't matter. You can put everything inside a list. That's why it's a trash can, because you can throw every shit inside of a list. Then we generate those objects. First we generate a matrix, then we generate a vector, then we generate an array, and then we generate a data frame. And all of these data objects we put inside of a list. And the list will look like this. So for the 5th element, we have the D1 object, which is one of our datasets based on the package datasets. And in the 4th element, we have our data frame. So each of those objects is inside one of the list elements. We can also adjust objects. We can say we want it as a list or we want it as a data frame. So we can adjust DA1 and make it a list. So it will put all of the columns in different list elements. We can also say we want DA1 as a data frame. Then it will look like this. Or we can also say we want a vector as a list, which will look like this. So every position inside of the vector will be a list element. This is kind of unpractical, so we won't use this very often, or we will use it never. So you also have to figure out which is the perfect storage for my data. We can also generate a new object, or we can reuse a variable name. For this case, we use D4 and generate a data frame out of D4. The next step is we look at the indication. So a vector is very easily to indicate. So for example, we use always those square brackets. So we put the position we want to have inside of those square brackets. So for example, we want to have just those positions which are higher than 200. So we put in this condition and we write the which function. So the which function will figure out the position of this condition. And this condition we put inside of those square brackets. So first we will run the which function and have a look on the positions. So all these positions are greater than 200. And we have a look at just this condition. Okay. This only shows us the Boolean values. And then we will have a look on the values of these positions. It's true, all these positions have a value greater than 200. We can also sum up the conditions. This is possible because true gets always the value 1 and false gets always the value 0. So we can sum up those values. So we see we have 89 values which are greater than 200, and we have 11 values which are smaller than 200 or equal to. Then we can also look at the length of our vector, and we see we have 100 values. Then we can show how to use a matrix and indicate a matrix. So this is our matrix. And when we want to see the second column, we use the second position inside of our brackets for the columns, and the first position is always for the rows. So if we put it in this space here, then we would indicate a row, and if we put it after the comma, we indicate a column. So first indicate the column 2, then we see we have indicated the column 2 and have the values 3 and 4, which is right. Then we can also indicate like the row 1. So we want to indicate the first row and leave this empty and only indicate before the comma. And then we get the first row. And if we want to do that, for example, for the second row and the third column, then we do it like this. So let's go to the data frame. They have a kind of different indication, but we will see. So first, this is very similar. We also can indicate from 1 to 10. So we see the first to the 10th value for the rows and all the columns. Then we can also indicate the second column with the particular rows we see here. But we cannot indicate like the fourth column because we have no fourth column, of course. And what we can also do is like indicate with a $sign. So after the $sign, we always assign the name. So in this case, the $sign is combined with the name of the column R beta. And then we can indicate this column with the $sign. Then we can also combine them. We can use the square brackets and the $sign to indicate that. And we can also indicate just with one value, then it will give us the second column. So then we can also say we want to replace the indication. So we indicate with a $sign, and then we want to say, so we want also to indicate via a sample. So we say we want random numbers from 1 to 100 10 times with no replacement. And then it will indicate randomly, like this time this values, and this time these values. And then we say we want this positions with a new value, which is an A, so not available. And then we can also ask if there is an A inside of our data frame in this particular column, and we see, okay, there are some NAs. Then we can also look at the positions we have NA, and we see these are the values for the other columns, and these are the values which we were putting the NAs in. Then we can just look at the right columns, so the columns where we have no NAs. So you can also indicate with an A. So we can say like, where is then A inside of my data frame? This is very useful when you want to adjust like missing values, or perhaps you want to impute them, so you can regenerate those values via computation from a different model, or yeah. So you can regenerate them with a different model. Yeah. So, and you can also ask which positions their NAs are. So which positions have NAs? And you see these are the positions with NA in it. So yeah, perfect. Then we come to the lists. The lists you have to indicate differently. So keep in mind we have L1, which is our list we generated beforehand. And so we can indicate a list element with the square brackets. And this is very important. We cannot make computations just out of this one square bracket. So this is not working because we only indicating an object and not the values inside the object. So we have to use double square brackets around the one. So we have 2 brackets before the one and 2 brackets after the one. And so we can make the mean value out of it. And that should look like that. And we can also combine these indication with the indication we did beforehand. So we can use also, say we want a 4th list element and we want this particular name from the data frame, and it will indicate properly. And we can also combine this with the square brackets afterwards, so we can indicate like this. This time we will care about the linear regression. The first and most used function in this case is the LM function. So with the LM function you can compute a linear model. So this is like the shortcut. So like LM is the shortcut for linear model. And you can write your formula inside. And this is your formula, which says like, this is your dependent variable and this is your independent variable. And then you can store this in an object, which is LM1. And then you can see the summary of LM1. So I will not go deeper into this. Perhaps I will make a video around it. So keep on watching. And you can also use the dim function to see the dimensions of it, and then you can like compare like the degrees of freedom with your rows here. Then we can also do this for another constellation, so also for D2, and then we generate the object LM2, and then we get this summary out of it. Then we can also try a multilinear regression. So we put more independent variables behind this tilde. And then we generate the object LM3 and make a summary. For the next part, I will show you how to use an GLM. In this case, we use a GLM with the feminine binomial. So our dependent variable is like has only 2 occurrences, and the occurrences of D3 and treatment are chilled and non-chilled, and so we compute a GLM model, and we have a look at it via the summary function. So the summary function is always necessary to see all the facts behind it, because if you only see this object here, you have less information. This also yields for LM1, LM2 and LM3. So if you want to see behind this object, you have to use the summary function. So that's for today's video. and we go through the functions we did. So we can ask if something is a particular storage, and that we do with isMatrix, isDataFrame, isList. We can also use isVector and so on. Then we can generate lists with the function list. We can also adjust a storage and make it a different one. So we can say as a list, as a data frame, as vector, and so on. We can randomly select values from a beta function with this value here, with this function here, or we can randomly select like this random values during the random unify function. And then we have the lm function and the glm function. Those functions are for like the linear model, and the glm function are for generalized linear models. That's for today. So if you like it, subscribe and comment and like the video, and I hope you learned something.